to the Journey Shake Chem. Well, please do the 2 warm-up questions to the best of your ability, and we will review them in a moment. In number 1, we are determining the number of ions. And in order to do that, we first have to find out the concentration of the solution. Well, we have 52.0 grams of zinc phosphate, and we must change our grams to moles. In order to do that, we need to have the atomic mass of the zinc phosphate, and we need to make sure that we have the correct formula. Well, on this we have 3 zincs, and each zinc has a mass of 65.4 AMU from the periodic chart. We have 2 phosphorus, which is 2 times 31.0. We have 6 oxygens, which is 6 times 16.0. And as you know, I write them again. And here I get 196.2 and 62.0 and 96.0. And when I add all of these numbers up, we get 354.2 grams per mole. That is our conversion factor. And because I'm going to grams, my grams go in the top. And it is zinc phosphate. And when I do the math here, I get 0.1468 moles of my zinc phosphate. Now, in order to get molarity, which is my unit of concentration, I must divide by the volume of the solution in liters. And I'm given milliliters, 550 milliliters, and therefore that must be changed to liters. And this bottom number is 0.55 liters. Now when we do the math here, we get 0.2669. I want 2 significant digits, and even though this is not my final answer, I'm going to use it. So this 6 rounds the 6 up, and I get 0.27 molar of the aluminum phosphate. Not aluminum, silly me, zinc phosphate. Now, when I put this salt into water, it dissociates. And as it dissociates, it becomes ions. It dissociates 100%, and I just have a thing with aluminum. It is zinc phosphate. And I know the formula is written this way because zinc is +2 and phosphate is -3. And we must have compounds equal to 0. So we get 3 zinc ions and 2 phosphate ions. And we found that we originally had 0.27 molar of the zinc phosphate. And I have 3 times as much of the zinc ions. And therefore, I get 0.81 molar of the zinc ions and 0.54 molar of the phosphate ions. And it's very important, as you noticed on the quiz, that you read the question. And when I'm talking about the ions, initially we have to solve for the concentration of the solution to begin with, and then we apply it to the ions. And that's how you do number 1. In number 2, we are given a concentration, and it is always helpful to write out the definition of the concentration. This means that I have 0.10 moles of my solute for every 1 liter of solution. It's important to distinguish between molarity is per liter of solution and molality is per kilogram of solvent. And it's very important to keep those 2 terms straight in your mind. Now I want to have the same concentration, but I want a different number of moles. And therefore I want 0.25 moles, and I want to determine what volume in liters that would require. Actually, I want milliliters, and first I have to get the liters. Well, I cross multiply here, and I get 2.5 liters as my answer, initially the number of liters. The question asks for milliliters, and therefore I must convert. There are 1,000 milliliters is equal to 1 liter, and therefore my answer is 2,500 milliliters of the compound, and it really didn't matter what compound we had. It was nitric acid, but you didn't really need to know that at this time for this type of problem. Well, there you have it, and you will be going over your quiz with the facilitator, and I hope that you can figure out the mistakes that you made. And we will be doing a lab in another couple of days, so we'll practice a little bit on molarity and molality for one more day, and then we'll move on to the lab. And I'm pretty excited about that because we get to do a lab that takes 3 days. It's so exciting. So I can't wait to see you tomorrow. Bye. Wait to see you tomorrow. Bye.